Cross. Hello everybody, if you didn't get my name at the start, my name is Peter Fretwell and I'm a Mapping and Geographical Information Officer at British Antarctic Survey. Alan originally asked me to do a talk on innovation in Antarctic imaging, and I thought, I could go away and research lots of things, and I became quite daunted by the whole idea of masses of innovation that I could talk about. So what I'm going to do is I'm going to give you some examples of some vast innovations that we've had recently, probably some case studies, and go over maybe about half a dozen new and innovative examples of remote sensing in Antarctica. Now, these are in Antarctica, but they are applicable, or the same techniques are applicable in the Arctic as well. I'm going to talk about half a dozen, two different types of studies we're doing on emperor penguins, looking at the distribution of population, both different techniques on each one. Vegetation, Antarctic vegetation, looking at the extent of species and change. Now, of course, people have been looking at vegetation for many years, but Antarctic vegetation is very sparse. Therefore, nobody's really looked at it before. So this has only really happened in the last couple of years. So, in that respect, it is quite innovative. And then, two things that we're starting to look at, so I can give you some preliminary ideas is looking at Antarctic seals, ice seals, and also looking into glacial meltwater and suspended sediments in glacial meltwater. So just a few case studies of new innovations using remote sensing. Why Antarctica? Well, as you all know here, I don't have to tell you hopefully that Antarctica is quite poorly known in comparison with most of the rest of the world. In mapping terms and in survey terms, we don't know as much about it as most other areas. And it is very important for the Earth system, the amount of fresh water and the effect it has on the global climate, very important things. So it holds a lot of very important questions. It's also very difficult to do fieldwork in Antarctica because of the extreme environment. Cold, windy, often very dark, very remote, and that makes it expensive. So often remote sensing is a really cost-effective solution to some of the problems that we have in Antarctica. So let's start with emperor penguins. It may surprise you to think about the emperor penguin, because the emperor penguin, we all know what it looks like. It's the star of several Hollywood blockbusters, well known, but we actually don't understand it very well. Basically because it is so poorly, so hard to get to its colonies. It's very remote, it's very hard to study. They breed in very remote areas. So it's a very good opportunity for remote sensing to engage with the public, to do climate change research, because it's a climate change issue here as well, and really we can showcase remote sensing in this way. So we've been doing quite a lot of work recently on emperor penguins. It's all new. To give you an example of how little we know, the main two things that we don't know are what the population is and what the distribution of the species is. Our knowledge is very poor on these things. This is a quote from Barbara Venneke, an Australian scientist, saying, well, how do you know what the population is if you don't know where they all are or how many breeding colonies there are? She did some work on the previous records of where we'd found emperor penguin colonies, and she recorded that, well, we had about 33 colonies that we were reasonably sure existed. Other records were quite poor, and she wasn't going to put those on the list because she thought they really were erroneous. But even many of these colonies' records are quite old, from the 1960s, quite a few of them date to. Many of them were taken outside the breeding season. The breeding season for an emperor penguin is in the Antarctic winter. Strange bird. It breeds between May and December in the cold of the Antarctic winter. So for fieldwork terms, it's very hard to get to it. So if you go in January, you may find a few chicks, a few old chicks, or a few remains of the penguins there. And several of these records have been extrapolated back and said, oh, we found 24 chicks. I think there was probably about 3,000 here. If you go back to October. So quite poor in that respect. So some of these records are quite dubious validity. The population estimates, if you add them all up together, depending upon which ones you believe, go about between 135,000 and 350,000 penguins in the world, emperor penguins that is. So you can see it's quite a large variance there. But we need to know, because the emperor penguin is predicted to decrease dramatically through climate change. It breeds on the sea ice, the frozen sea. So, because the sea ice is thought to be quite vulnerable to climate change, the emperor penguin is thought also to be at risk. Population studies and models from several sources have tried to estimate how bad it could be for the emperor penguin. Latest one, 2009, suggests that we lose about 95% of the population by 2100. And it doesn't take a scientist or even a satellite scientist to say that, well, if you go forward in time and we lose all the sea ice in December or November, then we lose all the emperor penguins. So it's quite key for us to find out how many emperor penguins there are and try and monitor them to see how well they're doing, if these predictions really are true. So we came up with a three-step plan for remote sensing to try and detect the colonies, try and estimate the size, and if we can, do some really quite detailed population counts. Our overall aim in this study was to do a global census of emperor penguins as a baseline to monitor future change. Now, if you think about it, the emperor penguin is probably one of the best animals to do remote sensing on. If you think about what criteria you need to look at something from space, well, first of all, it needs to be visible. The emperor penguin, or penguins in general, are black and white. So you've got white, breeds on sea ice, so it's black on a white background, so it's very high contrast. It's also got a unique signal. It leaves behind it a guano stain on the sea ice. Nothing else leaves this reddy brown stain on the sea ice. So you can go around and look, try and find it using this guano stain. It breeds in large colonies, and there aren't very many large colonies there, so there's probably about 50 or so. So you don't have to look at thousands and thousands of locations and analyse them all, only about 50. And each one is probably very large, several thousand bits in size. And then there's a need as well. There's a lack of current knowledge, as we've seen, and there's a need because of climate change. So you have both the ability and the need. So it's really good for remote sensing in those respects. So the first thing we started doing, we tried to find it by Landsat. Now this was quite a serendipitous discovery really, because we only discovered this by chance. Landsat's been around for 30 years or so, and penguins have been there for a long time. But it was only a couple of years ago that we realised that these brown stains on the Landsat scenes were actually penguin colonies. You can see here, brown stain in the middle, that's an emperor penguin colony, it's guano stain on the ice. So we thought, we can see the emperor penguin colonies, let's go and see if we can find some more. And then when we found, realised we could see all of them, we thought, we'll go and see if we can work out the distribution. So the Landsat's quite useful because each Landsat scene has a large footprint, about 200 kilometres by 200 kilometres, so you don't have to look at many to go around the whole coastline. It's ubiquitous, as Adrian said, and it's got multiple coverage over each area, so you can go back over each colony